In this example, we have 2 points A and B whose position vectors are given here. Position vectors are always given relative to a fixed origin, which we often call O. Our first task is to find the vector going from A to B, and then show that triangle OAB is isosceles. Well, if we have an origin, let's say it's here, and point A up there and point B here, this little sketch will help here, even though we are in three-dimensional space. Doesn't matter, the sketch will help. So we know the position vector of A. So that is a vector starting at the origin and finishing at A. We also know a position vector of B. So we know a vector going from the origin to B. If we want to find the vector starting at A, finishing at B, so this one in other words, then we can use the two vectors we've already got to get from A to B. We're just going to go a long way around. So we're going to go first of all from A towards O, and then from O towards B. So in other words, we're going backwards along the OA vector and then forwards along the OB vector. That's what we've got here. We're forwards along the OB vector and backwards along the OA vector. We could have written those the other way around. You could have written minus OA and then plus OB. You could have even written AO first with an arrow on top and then plus OB. These all mean the same thing. So that gives us the vector AB, and it turns out to be -1, 2, -8. We now need to show that triangle OAB is isosceles. So here's a very rough sketch of my triangle. And again, in reality, this is in three-dimensional space. Doesn't matter that we do a little sketch, it helps us make sure we're doing the right thing. So if it's isosceles, then two of its sides will have the same length. So if we're going to show it's isosceles, we need to find the lengths of all the sides and show that two of them are the same. So here we go, using 3D Pythagoras, the length of AB, make sure you square -1, important brackets here, plus the square of 2 plus the square of -8. Do a similar thing with the vector OA, which tells us how long the side OA is, and also how long the side OB is. And we see two of them are the same. So sides AB and OA. Notice I haven't put arrows on these. These are not vectors. I'm just calling these the sides of the triangle. They have the same length. Therefore, the whole triangle is isosceles.